Monday. All right, first off, we have Dustin from ASCE. He's going to tell you about the program, and I'm assuming invite you to a meeting. We'll pick up in your own class.
Thank you. All right, guys. Again, my name is Dustin Pepley. I'm the president for the American Society for Civil Engineers on campus. Some of you might know me or have heard this speech before, but if you haven't, you can pay attention. What the professional society I'm involved with does is develop students professionally. So while you're getting developed academically and getting smarter, you can also develop yourself professionally so that you know how to talk to business professionals and build a network so that when you leave college, you can be set up and ready to go. So I'm just going to go through this PowerPoint real quick. I don't want to take too much of your time, but basically what we do is, see, the ASCE was founded in 1852, civil engineering. Now, I understand everybody in here isn't a civil engineer. You guys are mechanical or whatever. That's even better for you because then you can practice talking to civil engineers and it won't even matter by the time you're done. You're ready to talk to mechanical engineers. You know, you won't mess anything up. You'll be ready to rock. But anyway, it's been around for, let's see, 150 years now, whatever, 160. And basically, the national organization enforces standards and ethics with engineers. So again, we're a professional side here on campus and we focus on developing students. So let's see. Yeah, you guys can read. All right, so basically competition teams. That's what everybody seems to be interested. That's what brought me to the ASC. Is how I got involved, actually with water treatment. And I was on the canoe team last year, and I'm going to be captain of the canoe team this year. Here's a picture of the water treatment. This is a Mid-Pacific conference. We travel down every year. We compete regionally in our competition. We have Steel Bridge here. This was just brought back last year. We got 7th place, but we didn't get disqualified, which is a good thing because most people get disqualified. But this year, I'm thinking we're going to go to nationals because we have a good team built up. And you guys are welcome to come join our team. And if you like, it's if you want to come join. See, I think I have on here my contact information. I'm not sure. I kind of threw this together. This is our country canoe team from last year. Let's see. Here's I'm going to show you guys some paddling. This is the girls' sprint. And that canoe is actually made out of concrete, if you don't believe it. If you don't believe it or not. Now, you can't really get a speed aspect of how fast they're going, but they're like going really fast through the water. It doesn't seem like it. So I brought this other video up so I could show you guys. This is, we hosted the national competition this year at the Sparks Marina. So I'm going to go ahead and play this video for you real quick, just part of it. That's actually my daughter right there. I don't know, Kara, but she was our mascot. She's pretty much the coolest person there, whatever. So we're getting ready to start the race here. This is Mitzi. She graduated last semester, but and two, I mean, it's another thing is she wasn't like a great student. I don't think she had like a sub 3.0, but she's running a lab, and just because she was involved with concrete canoes, she made the mix that boat was made out of, and she knows because she knew so much about concrete. Baker, the guy who owns Baker Construction, called him up. Hunker called him up to called her up and offered her a job. But see, now you can see how fast we're going. We're screaming. So anyway, I'm not going to play this whole thing for you. It's a lot of fun. Get out of this. Bam. Hold on, just give me a minute. I'm almost done. I know you guys want to hurry up and get to class. So anyway, we have events. We schedule them. I scheduled 12 events this semester. We had 14 last semester. We just had a couple more days. This is 2 past presidents. We're building. Let's see. We were trying to build the tallest tower out of spaghetti sticks and marshmallows. See, barbecue. There's actually a lot of people inside the barbecue. I didn't have any other pictures of the barbecue, but that's a couple of our members. And let's see, this was a talk we had last Thursday, actually. We had the I-80 construction manager, the quality assurance manager that did this whole project out here on the freeway. He came with a chief estimator from Granite Construction. They gave us a talk about the bid process. And there's about 30 people in this room in the back. You can't see them. But free sandwiches at all our meetings. Our next one is, I don't have my schedule with me. You guys can come to the ASC Lounge and find out, though. We're actually doing a tour for the next couple of meetings. We're going to be going out to the Nevada Cement Factory this week on Thursday. If you guys are interested, the SEM119 is where our lounge is. We have 10 computers in there with all the programs that you're going to need and use. And right now our printer's broken, but we generally have free printing. So here's we're tutoring some high school students, teaching them about statics, actually. And this is a tour of the Stampede Dam. So we actually got to go under the dam 200 feet below the ground all sorts of stuff. It's a lot of fun. Yeah, 200 feet below the dam right there. So this is our lounge, and a couple things. We offer free tutoring, so if you guys need help, we have a tutoring program lined up. We tutor statics, dynamics, and other things, more higher level stuff, but if you need help with anything, you guys can all come in there, and everybody in there, whoever's in there will help you out. They'll stop what they're doing to help you out. Also, last thing, so if you guys come to our meetings or you get involved with volunteering or helping us out, for every hour that you volunteer, we're going to give you 1 point. So we call it professional development points for students, or student development points. But if you guys come there, then our end of the year raffle, we're going to actually, so basically, every point you have, every hour you contribute gets you 1 point. That counts towards a ticket that goes into a raffle, and we're going to raffle off $1,000 in cash in our last meeting. So, bam, there's my contact information. You guys want it? I'll leave that up.
Yeah, I'll put it on our website.
Cool. That's it. Thank you, guys.
Thanks, Stephanie. All right, give me a minute to get switched over here. I'll get this his contact information up on Web Campus for you guys. But ASCE is a great organization to get involved with. It's nice to make friends within the engineering school, for one. Two, those professional contacts are so key when you're out looking for a job 4 or 5 years from now. Everyone you know counts, so be sure to take advantage of those situations. And let's get our clickers set up if you guys haven't already. Okay, you guys ready to sample question here? Is your clicker working? Yes or no? Let me just hit play. Oh, 600 seconds. Wow, we don't need to go there. I guess I could have started this a while back, right? Okay. Yeah. You guys are going to have about 15 seconds when I get done with this. Okay, 10. Remember, the clicker counts towards your grade. A small portion, but it counts towards your grade. Yes! Whose clicker is not working? If it's not, make it work and get going. You guys have a couple minutes before my first question. I like that. I'm not sure. That's why I'm checking. Okay. So, some reminders for you. You guys have tons of due dates coming up and things to do. First off, your rental kits are available for pickup in the EDL for $50. You need to go to the cashiers first, pay them, bring your receipt to the EDL, and a TA or Dr. Lacombe or I will get you your kit. Please make sure you do that. The fuel cells are included in that cost, but they will not be in your kit. You'll get them in a few weeks in class. Okay. Journals. They have started. You need to keep track. You have a journal entry due every week in your skills lab. At the start of skills lab, they will ask you for it. So make sure that you get those done and document your progress. Okay? Dr. Lacombe talked about those last week. Be sure to be honest with the work distribution. We understand that some weeks you might contribute a whole lot and some weeks you might check out a little bit. Maybe you've got a zillion tests or you're sick or whatever. Just be honest. Okay? It's easier to keep track of you guys as a group. It's easier for you guys to be accountable within a group if you're honest. If everyone has equal work every week, I highly doubt that's true. Okay? So be sure to be honest with those. Your first CATME survey is due tonight by 11:59 p.m. Who's done those? All right. Okay, good. You guys have a second one coming at you. I think you guys got the email already. That one you have until next Monday. So we're doing them these 2 weeks, and then you have a week off, and then we'll do another one. Okay? This allows you to be, again, accountable within your group. If you guys are having any problems in your group, please express that in the CATME. I go through and look at it, and so does Dr. Lacombe, and it will flag groups. So if you are having problems, which I hope none of you are, but if you happen to be having problems, please document it in CATME so that we can follow it and maybe talk to you guys if that needs to happen. Your online safety module and quiz is due Monday, 10/1, that's today, I believe, at 11:59, or sorry, that's a week from today. Okay? Your safety quiz is due, don't forget that. Last step, watch the soldering video before your skills lab. Okay? Skills lab 6, there's a soldering video on Web Campus, make sure you check that out so you're ready for lab. Anybody questions? These are awfully chatty. No one has questions? Okay. So your first or second clicker question, however you want to look at it, is what percentage is considered a passing grade for the safety quiz? 50%, 60%, 90%, 100%, or 110? What percentage is considered a passing grade? Ten seconds. Enter in your answer. 3, 2, 1. Let's see what we got. This is looking good. 98% said 100%. You 98% are correct. You need 100% on your safety quiz. You can take it multiple times, but you have to get 100% or you cannot participate in the lab. Is in building your hovercraft. So please make sure to take your safety quiz over and over and over and over and over until you get 100%. Okay? Okay. Another clicker question for you. Your calculations show you need a pressure of 0.08 inches of water and a flow rate of 80 CFM. For the fan curves shown, how many lift fans do you need? 1, 2, 4, or 10? So you need 0.08 inches of water, and you need 80 CFM. How many lift fans do you need? I'm gonna minimize it. It's okay. Ah. Five seconds, get your answers in. 4 fans, 84% of you are correct. Let's take a look at this. Okay, if you need 0.08 inches of water, this comes up on your midterm and in checkpoint 1 and everything else. 0.08 inches of water, we come across to the fan curve, and when you hit the fan curve, drop straight down and you'll see that you get 20 CFM available from that fan. Okay? When we're talking about lift, we have to make sure we can meet the pressure. The pressure is very, very, very important because it's the pressure required to get your hovercraft up off the ground. So if you need 0.08 inches of water, come over to 0.08, or up to 0.08 I should say, over to your fan curve and drop down. This one fan is giving you 20 CFM, but you need 80. So 80 divided by 20 is 4, so you need 4 lifting fans. Okay? The pressure required does not add up, it just go to the pressure required you calculated, you can add up the CFM with different fans. Okay? Questions about that? Okay, good. Just a quick review question. So you need 4 fans. All right. So today, I've got a very exciting topic. We're going to talk about writing reports. Yes! I know engineers love to write. If you don't agree with that statement, please embrace it. You will spend your entire 4 or 5 years here, or 8 years, or however long you're here. Plus, hopefully not 8 years, but you never know. Plus, when you go into the workplace, engineers spend tons of time writing. You're constantly writing reports about what you've been doing. You're writing proposals about projects and what you need to do and keeping your boss happy. You're constantly writing emails. Okay? Everything has to be professionally written. So the engineering writing style, technical writing, is a lot different than everything you guys are used to. For the most part, I'm guessing. Most of you guys are probably in English 101 or 102, okay? Or you will take it, and then you'll take your core humanities, and you've had your 4 years of English in high school, and a lot of that writing has been creative writing. How do you feel today? Write about the most exciting moment you've ever had. Okay? Write about a book. Okay? You can look at, I don't know, The Great Gatsby and prove the symbolism within the book, something of that nature. Those are things you guys are probably used to writing. Who's written a technical report? A few of you guys. Okay, good. So you guys are all set. But let's go. We're going to go through what is due. You guys have a design concept report due on Wednesday, a week from Wednesday. So we're going to go through the elements of that report and what goes into it, and we'll talk about writing a little bit. And then you guys might have a little bit of time to do some quick planning within your group. All right. So first off, the one thing everyone really needs to know, you have a hard copy due in class at 4 p.m., one per team. So one person in your group, make sure you print it out and bring it to class on Wednesday, October 3rd. So a week from Wednesday, you guys will bring your report. That night, by 11:59 p.m., you need to have a PDF uploaded to Web Campus. One per group, again. Okay? So maybe the team leader or whoever you guys work it out, the lead writer, someone better make sure that report gets on Web Campus by 11:59 and a hard copy comes to class. Okay? So late things are not accepted. Don't miss out. It's a lot of points. So next Wednesday. All right. There is a grade sheet in Web Campus. It's in week 5, and it's also in your deliverables folder. I would look at Chapter 11 in your textbook. Chapter 11, not only do you have a reading quiz, but it's all about technical writing. So that will help you get started. Okay? You want to read the assignment description on Web Campus. We give you guys descriptions that break down the points for pretty much everything. So the first thing you want to do is make sure that you've met all the requirements. If you met all the requirements, your grade can't be that bad, right? It'll be great. So make sure you meet the requirements first. Use your textbook as an example. The textbook references things the way we want them referenced. Figures and tables are labeled the way we want them, equations, all those things. Your textbook is a very good reference for what a technical document should look like. And we're going to break it down. Just here's some first things to go by. The report is used to sell your design and provide the facts. We want to know, what is your plan for this hovercraft? How are you going to get to the end of the course and back using a fuel cell, using lifting fans, using batteries? Okay, what kind of deck are you going to use? What's the shape and the weight and all that sort of stuff in all these calculations? So you guys are going to put together a concept on paper. That might sound a little scary right now at this point in the semester, but I believe in you. I think you guys can do it. And the nice thing is, this is a jumping off place. Get it all on paper. Things will probably change. That's part of the design process, is that reiteration, and that's okay. But come up with a sound design as a group and get it on paper. And that's what we're asking you to do with this report. Okay? So just the facts. Again, it's not creative writing. You don't have to come up with a bunch of fancy adverbs and things like that. It's just the facts. Make it easy to follow. You want to provide a clear outline. We have given you the sections of the report on the grade sheet and exactly what needs to go in them. Make sure you have those sections in that order with what goes in them, and you will do well. Okay? You need to use figures, tables, and equations. We engineers typically like pictures to look at. It's much nicer than just reading a bunch of text. It makes things easier to read and more entertaining. So make sure you have figures. Because someone should sketch or draw a picture of your hovercraft. Use CAD if you can. Okay. You're going to have tables showing the weight of your hovercraft. You're going to have tables showing your budget and your Gantt charts, your schedule. And you'll have equations for lifting fans and your propulsion fans, or not propulsion, sorry, lifting fans and your battery calculations. So all those equations are going to go in this report also. Yes, question? Your equations, he's asking, are they rough estimates or exactly? You will show, and I'll show you an example, but you'd have, for example, pressure required equals weight over area equals, say, 5 pounds, whatever you estimated, over the area of your deck. So like that one should be exact. That might change. You might find that the weight and area you chose, something's not quite happening right, and you need to get up higher, so you might make your area bigger. Does that answer? But you want exact numbers for this report. Yes, you want to have, he said, exactly what I planned for my hovercraft. Yes, put those exact numbers in your report. Okay. All right. You need to number your pages. That's an easy one. You can do that in Word. You need 5 pages, not including the title page. So 5 pages, most groups, there's 4 to 5 people. It's not so bad. Submit 1 copy again on Web Campus, and you'll submit a hard copy in class. Okay, so that's kind of the basics. What I want you guys to do is make sure you go to the grade sheet, and I'll put it up here in a little while so we can go through the various sections. But make sure you address every section. Okay? All right, moving forward. Along with your design concept report, you guys need to turn in a work distribution form. And this is the individual effort on the report only. Okay? So you have a workload that has to equal 100% between 4 or 5 of you, or maybe 6. So write down who did what and divide it up into a percentage that's truthful, and include that with your paper. Okay. So parts of the report. You have your title page. Everyone's like, I'll do that one. You have an introduction. Then you're going to have a background. Okay. Then you're going to have the concept description. That's the meat and potatoes of your report, all those calculations and things. An estimate of resources, so your budget. And then last but not least, you're going to have a project management page or section with your Gantt chart. And so for the next few minutes, I'm going to break down each section for you and tell you about them and what goes into them. So, title page needs to have the project title. Go figure. Okay. The assignment name, that's design concept report. The course number and name. So, ENGR100, Introduction to Engineering Design. This is all online. Team number. Your team members, make sure you use your first and last name. There's a lot of you. Please don't just put first names. It'll be very hard to track you down. So first and last names. You can indicate if you want next to someone, lead author, team leader, or something like that. If they have a specific role in the group, that's okay. And then last but not least, the date that it's due. Again, that's October 3rd. So make a nice title page. Probably last. And then we'll go on to the introduction. The introduction includes the goal of your project. What do you have to do? What's the design problem? You guys need a hovercraft that autonomously can get to the end of the track and back. Okay? That is your goal for the semester, among other things. You need to indicate what the scope of the report is. Okay? So that's talking about this is our design concept, our preliminary design, what we've come up with, or whatever. You can go from there. And this report will discuss that. You can talk about the motivation or significance of the hovercraft project, of being in ENGR100, that sort of thing. You can talk about the project objectives. The main objectives are follow the course with using a budget of $300, okay, etc. Working in teams, all that sort of stuff. Learning some basic engineering concepts. And then you can summarize the rest of the report. So this report includes blah, 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 blah. And we'll get there. Okay. I would suggest that you write your introduction last. Or maybe outline it and then go back and fill it in at the end. Make sure that you read it last because that's the first thing people read. When you hand someone a paper or something for work, some sort of document, a lot of people are really busy. And what they're going to do is they're going to read that first paragraph. And if that first paragraph doesn't capture their interest, they're going to be like, meh, throw it aside. Okay. We as teachers have to read this. So, you guys are great. I'm like a class of 500, there's going to be no interaction, and you guys still manage to make fun of me. I love it. Okay, so back to this. Where was I? You guys completely lost me. Anyway, summarize your part. Write your introduction last if you want. Make sure that it's good and it captures the interest. Okay? Make sure there isn't a run-on sentence or half a sentence, like a subject with no verb, your first line out. That is not going to bode well for you. Whoever's reading it's going to be like, F. No. So make sure you do well with that. Assume your audience is a high school senior. We always want to make sure that we're writing to the appropriate level of our audience. I'm going to tell you right now, your audience is going to be a high school senior that knows nothing about hovercrafts and is not technically inclined whatsoever. They are not in the engineering department or science or math. Okay? So that means you got to start from the basics and build from there. Don't assume that Dr. Lacombe or I are reading who have designed a zillion hovercrafts. Okay? Assume it's a high school senior who's never seen a hovercraft. Questions about your intro? Okay. All right, the background. The background is not the history of hovercrafts. We covered that in class. Okay? I don't care about hovercrafts getting across the English Channel at this point. The background for you in your paper, okay, is how a hovercraft works, so the basic principles of lift, that sort of thing. And then relevant research that your team has completed. I hope you guys have all started thinking about your hovercraft and done some research. Okay? You might get on YouTube and see a circle hovercraft, a circle-shaped hovercraft that's a complete disaster, and then you see a square that's awesome, and there's some explanation as to what is going on, the circle's spinning everywhere, and you're like, wow, we're going with a square. Design decision number 1. Okay? Put that in your paper. Why did you decide on that shape? And have a reference. You must reference everything you put in your paper in this background section. If you pull information from a subject, or from a source, whether it's a textbook, online, YouTube, an older student, anyone, when you pull information from someone, you have to summarize what they said, and you need to reference it. Otherwise, you can get called out for plagiarism, and that's not good, right? Don't take direct text and throw it in. It's very easy to see for the most part, especially now with the internet. You can type someone's sentence in Google, and it'll show you exactly where it got pulled from. So make sure you're summarizing, not copying sources, and make sure you're referencing them. So again, you guys are going to be doing research. At the very least, you'll reference your textbook. I know you guys have gotten information from your textbook if you've been doing your reading quizzes. Okay? You guys might want to look at other books, periodicals, again, YouTube, internet sources, whatever it is, but make sure they get referenced and it goes in the background. Okay? And that's all the things that help you make design decisions. If you see some method for propulsion that you think is really interesting and you want to try that, write in your background section. We got this idea from blah, blah, blah. Okay? Questions about that? Okay. All right, so then we get to our description, and this is the meat and potatoes of your report. This is where you talk about the deck. What is it made out of? What are the dimensions? Okay. How heavy is it? All that sort of stuff. You're going to talk about your lifting fans, and that includes going through those lifting fan calculations. You will record in your report each one of those equations we went over in class and have numbers, real actual numbers that correspond with those equations. So your lifting fan calculations go in your report. You're going to show the equations, the calculations, and the results. And equations get their own line. I'll show you guys in a little bit how that works. Okay? Do not include your spreadsheets. I know you guys are great at Excel at this point, and you guys have an Excel spreadsheet that does calculations for you. You can't just put it in a spreadsheet because remember your audience, you've got this high school senior who doesn't know where those numbers are coming from. So we got to show the equations, not the spreadsheet. For your batteries, you want to talk about what type did you choose, okay, and why in your background. You're going to do your battery calculations. How much time am I getting out of these batteries? And how much voltage? How many batteries do I need? All that sort of stuff. Are they in series and parallel? What do I have going on? That goes in your paper. Then you're going to have your estimated weight, okay, your propulsion technique that must use the fuel cell. Okay, so start thinking about that also. You will have drawings. They can be hand sketched. That's okay, but make sure you use a straight edge when you hand sketch them. Don't hand sketch something on lined writing paper and attach it to the back of your paper and expect a good grade. Okay. Sketch them so they look nice, scan it, and put it digitally into your paper. Anybody questions about? Yes. He asked, are we worried at all about the Lego NXT and the sensors that we're going to be using? As far as the description goes, I would say that yes, if you've made those decisions, put in a paragraph. Mainly we're looking for your propulsion technique and lifting, but yeah. Anybody else? Okay. So next section, figures, tables, and equations. These can be tricky to present. If they're kind of a mess in your paper, then it's a real big distraction, so we want to make them look good. First off, you need to number and caption all figures and tables. If there is a figure or table, which there will be, in your report, figures get captions below and tables get captioned above. And it should say something like this: Figure 1, hovercraft lifting fan. Okay, so I can flip through your paper and be like, oh, there's a hovercraft lifting fan. Or Table 3, project budget. Make sure they all have captions or you will lose points. You need to number all the equations. So equations come up and you have, for example, you might have x squared plus 3, and that's equation 1. So your x squared plus 3 goes in the center of your paper, and the one with the parentheses around it goes justified to the right. Same with down below, we've got force is pressure required times A. A really nice way to put in your equations is if you go to the Insert menu in Word, there's Microsoft Equation Editor. You guys used that before? Some of you? You can type in equations very quickly and very efficiently, and they look really nice. If you just take like screenshots of the equations we showed you in class, they will look terrible. So make sure you use Microsoft Equation Editor. It doesn't take that long. It's super convenient, and you'll use it all through school. So make sure to do that. Last but not least, you must refer to figures and tables, and equations for that matter, in your text. If I'm reading along and a figure comes up and it hasn't been talked about yet, you've got a problem. You will lose points. So make sure you have something in your text before that figure. So it says like, Figure 1 shows a sketch of our design. There can be some writing after that, but Figure 1 comes somewhat close to there. As Table 2 clearly shows, our budget is $145. Make sure you are referencing figures and tables in your document before they show up. And make sure they're in order. Figure 3, surprisingly, comes after figures 1 and 2. So sometimes you'll see in someone's paper, it's like Figure 2, Figure 4, Figure 5, Figure 1. I don't know what's going on with that, but make sure they're numbered in order. Okay. Figures typically are pictures. Tables have rows and columns. Okay. Any questions about this stuff? Yeah. The equation editor, he said, where is it on? If you go to Microsoft Word and you go up to the very right-hand side, it says Insert. And then there's a pi sign that shows up. Click on that. And you can type in equations. If you have questions about that too, you can ask your TAs or ask Dr. Lacombe or I. We can help you also. Anybody else? Yeah. You do need to know how much power, if you can get at that number. Mostly we're looking for the technique. What are you planning to do, and how does the fuel cell involved? Yeah. All right. So next up is your budget and your bill of materials. So the bill of materials is a parts list, and it's got quantities and costs and vendors and sources. You might as well put a total cost at the end, or the price per item, and turn it into a budget. You guys have one in your Excel 1. You guys did. It had decorative parts and batteries, I think, and fans. Do something like your Excel 1 homework, but update it so it's useful for your project and reflects what you think you will be buying. So you're going to have to do a little bit of searching online, go to DigiKey, see how much the fans are you intend to use and that sort of thing, and make sure that you present it well. One thing on tables, do not split a table over 2 pages. If it doesn't fit on the page you're currently on, put it on the next page. You can fill in with text in between. Okay. Don't let them split the pages. And then also, when you're talking about your estimate of resources required, again, you're going to put in a table with your budget. But since you have a table, that means you have to talk about it. So we expect to see at least a paragraph about your budget and where you're at with it and what it includes and all those things. Make sure you talk about every table, figure, and equation. Don't just throw it in there with a section title saying estimate of resources. It needs a paragraph. Oh, for your budget too, in case you haven't figured this out one yet. If you go through, say you decided to do non-rechargeable batteries, which you guys won't, but if you decide to do that, and your hovercraft took, I don't know, 20 batteries, so you put that in your budget, but then it turns out that you actually used 100 batteries because you were testing it a ton, all 100 batteries go in the budget. So if you have a deck that doesn't work out and you have to upgrade to a new one, both decks go in your budget. For your report, you'll have probably one of everything because you won't foresee these problems yet, but in the final report, you might have 2 decks or an extra battery set or whatever it is. Okay, make sure it all goes in the budget and stay under budget, please. All right. Project management. You need a Gantt chart. You can check out online, there's a really cool video, not really cool, but it's a really functional and useful video on making Gantt charts in Excel. The guy walks you through it step by step. It's very easy to follow. Please watch that video before you create your Gantt chart if you're not sure how to do it. The Gantt chart is a project schedule, and it includes the group checkpoints, okay, checkpoints 1 through 5 at the minimum, plus your 2 papers and 2 presentations. So things you turn in as a group towards your hovercraft project go on the Gantt chart. You can put in other checkpoints for your group if you guys have some other things, some small milestones or things you want to add in, you can do that. But the bare minimum is 5 checkpoints plus 2 papers, 2 presentations. So you can see across the x-axis there's dates, okay? Or you could do weeks. I don't know, my life is in 16-week semesters lately, so that works for me, but dates probably work better for you guys. And then along the y-axis you'll see the tasks. So checkpoints 1 through 5. Yeah? He asked, do you want us to only use Excel or can we use another program? I don't mind if you use another program. I've seen in the past other programs make things that are very busy and hard to fit on one page. So it's up to you. Make sure it's clear and concise. Okay. So you want to include all deliverables. Again, there's links and there's videos online to help you. Okay. So since we're going to have this lovely figure, we need to have a paragraph. And in that paragraph, you can talk about team member responsibilities. So what are the different roles and who's doing what you guys have accomplished, some potential problems and response plans. You might foresee that, I don't know, 2 of your members are going to go to Mexico in the middle of the semester or something, and you need to deal with that. You might foresee that you didn't order, I don't know, the right fans or that whatever's going on. So if you can foresee any problems pertaining to your hovercraft or your group, you can put those in with some response plans. I think that about covers that. So anything, responsibilities, anything to do with the group dynamics goes in this section. Okay. All right. Next section. Oh, here's a Gantt chart, sorry. So here's an example of a Gantt chart created in Excel. You will see that I've got checkpoints and reports and some other things in here, hovercraft fabrication time. Okay. So this is saying my fabrication, it's saying that it's delayed right here, that's in black. That's delayed because I ordered my materials and they're not here yet. And then this is the time I'm working on it. Okay. And it's done at the end. Pending down here in red, might be waiting for that final competition. I'm all done and ready and just waiting for my final day. So you will have a chart that looks like this. Hopefully using Excel or something else that looks nice. Okay? Questions about Gantt charts? Okay. It's a project schedule and it's used. You guys are going to use this to keep on track. I would encourage the group when you get together, maybe once a week when you do your journal, update your Gantt chart because you're going to use it at the end of the semester also. So if you keep it up to date, then it's easier to follow. All right. References, everyone's favorite thing, I'm sure. You will have a numbered list of every reference that was in that background section or anywhere else in your report. If you pull pictures or something from a website, they have to be referenced. In engineering, we use references. We list them in the order they appear. We do not list them alphabetically. They go in the number they appear. So if I am reading through your paper and I come across such and such and such and then a bracket and a 1 and say it's for the textbook, when I flip to the back of your paper and look at reference 1, it had better be the textbook. Okay? So make sure they go in order, and they get denoted like this. You'll see in this first bullet point, it says, Smith and Jones describe lifting fans. And we use a square bracket, okay, and put the number of the reference. And then at the end of your paper, you'll have a list of references. More than 2 authors, you can say Smith, and then this funny little thing called et al., E-T space A-L. It's Latin, et al. That means everyone. Smith and a bunch of people. Okay. The textbook has really good examples for references. You guys can see when you read through the textbook, you see lots of these brackets with numbers. Flip to the back of that chapter and you will see the full reference. All right. Any questions about those? Okay. All right, so to write, the textbook has some ideas for you for a method. Here's a summary. First off, quick plan. I would suggest when you leave class today, if you can find your team members, start breaking down the sections a little bit and say, hey, will you go look into decks, and will you look into lifting fans, and will you look into plenum chambers and whatnot, propulsion. Divide up and do some quick planning. Who can do some research for you guys? Okay. You guys have about 10 days to do this paper, so you got to get motivated quickly. Then you guys need a draft copy. This is where you just start writing. Okay. Come up with some ideas. Write it up. I would suggest in that when you do your draft copy, you come up with an outline to start. So what do I need to cover? And you can fill in that outline. So if you write an outline about what each section is going to have in it, and then you can write some topic sentences. And remember that if I read the topic sentence, the rest of the paragraph must match that topic sentence. Something we all forget sometimes. Okay? So make sure your paper can be read very, very clearly. So you have your outline, do your draft copy. And then set it aside. Your brain does funny things to you. You think you've written a perfect paper, and then you'll go back and read it the next day and be like, wow, oops. Missing things, typos, all that sort of stuff. Okay? So that's when you want to run your spell check and your grammar check and give it to another person in your group to read what you've done. And then you're going to start cutting and pasting everyone's work into one final copy. And make sure your figures are in there and your tables and everything's in order and all makes sense. I would suggest that your group chooses one person to be kind of the final copy editor to make sure it all flows together and makes sense. Writing is a difficult process, and it's time-consuming. Start early. If you guys start this next Tuesday, you guys are going to have a long night and a long day Wednesday. So make sure that you go through, read the grading rubric, and make sure you have every section covered. Okay? Make sure that you've adequately described everything, and make sure that you have left out typos and all that good stuff. So you're going to have to do lots and lots of editing. Edit, 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 edit. Edit, you'll see off the page. Okay, so this is going to take some time. All right, can you read this? Take a look. Good. I put this up here because of this statement. The fact that you are familiar with your writing triggers your brain to autocorrect, kind of like your iPhone, right? It autocorrects to embarrassing things. Make sure you set your paper aside and read it later or give it to someone else in your group to read your section. Your brain fills in words for you, and when the person grading your paper goes back and reads it, those words aren't there anymore. And it doesn't make sense. So please make sure that you review and edit. Okay? Make sure you have complete sentences and all that good stuff. All right, common mistakes that we see in here. People not writing formally. You guys are used to creative writing. This is not creative writing. It's just the facts. Okay? You don't need any fluff, just content. By that I mean we see things like this. We dream. Okay? This is the best, coolest in the whole wide world. I have no idea what this group was talking about. The fear of swine flu is turning age-old rituals on their head. Don't ask. I don't know. What used to be okay is not anymore. Please leave all that stuff out and just get to the point. That's what we're looking for. Okay? We're looking for your hovercraft design, describing your design and what you guys plan to do. That's what we're looking for. Okay? No abbreviations are acceptable or slang or text writing shortcuts. I realize you guys love to text. I love to text, maybe more than you. Okay? But you can't turn in papers with text writing. No LOLs, OMGs, W somethings, any of that. Make sure, okay, we don't need emoticons either. No, our hovercraft is great, smiley face. It's not appropriate for technical writing. What you write, okay, needs to be a representative of you and your group, and you guys are professionals. So make sure when you write things for this class, whether it's this paper, emails, homeworks, whatever it is, write professionally. Don't use text speak. All right, make sure that you label your figures, tables, and equations. Don't cut off your figures or shrink them down to an inch-by-inch picture. I can't read it. Consider me blind. Make it so I can read it. Okay? Make sure that you use your Microsoft Word tools like equation editor, and it has auto-captioning, that sort of thing. Make sure to do that. I have a clicker question for you guys, so hold on. Yes, question? Hold on, I can't hear. Can you guys, I still have 5 minutes. Please don't pack up yet. Go ahead. Your paper needs to be 5 pages. So if you've gone over 5 pages, then you've probably put in too much. I had this English teacher, and she said that, you guys like this, the length of a paper is like the length of a good skirt. Long enough to cover the topic and short enough to keep interest. We think 5 pages will work. Okay. Nice, okay. All right, question 3 on the clickers. What stage in the design process is your team at? Our team really hasn't gotten together yet, option 1. Option 2, we have started the initial brainstorming. Option 3, we have done lots of brainstorming, but no decisions have been made yet. Option 4, we've started lift calculations based on our selected design. In option 5, we have finished our preliminary design and selected our fans. Ready, go. And I have a couple more things for you, please. Sorry. We're done at 4:50. That's 4 minutes from now. Five, 4, 3, 2, 1. All right, let's see where everyone's at. Somewhere between initial brainstorming and lots of brainstorming. Some of you guys are way ahead. All right, so you guys, this paper means you got to get moving and make decisions. Okay, something else, big news here. Your checkpoint 1 is coming up. It's on Thursday or Friday, October 11th or 12th. There is no main lecture on that Wednesday, October 12th. Yes. Okay? You need your calculations and your parts list with you on the grading sheet that's on Web Campus. It's worth 25 points. Please go to deliverables and checkpoints and check out checkpoint 1. I'm going to show it to you real quick. There's a description, and again, there's grading criteria. Make sure you have everything we require, and that gets you off on the right foot for getting a good grade. You can come on Thursday and Friday between 10 a.m. and 7 p.m. At 7, we lock the doors. At most, only 1 team member can be missing. The later you come, the longer you'll wait. There were times last semester when people waited 4 hours. I would suggest getting done early and coming Thursday morning. Okay? Then you get your Friday free, which is also nice. But the earlier you come, the better off you'll be. So please start early on your checkpoint so you can get done and not wait in line. So you've got this grade sheet. When you look at these, there are a couple things. In red, it says, you guys can't read it, but it says to be completed before the checkpoint. Make sure these pages are done. And they're basically, you're going to take your calculations, and these are summary questions based on those calculations. So make sure these are filled out and ready to go. Then, all right, next, there is a grading rubric. So the first one is here. This is asking about propulsion technique. To get full credit, propulsion technique proposed is viable and entirely actuated by the fuel cell. Okay. Look at the rules for the hovercraft. Make sure you read the specifications and make sure that you meet them. Okay, so we will fill this out for you. Bring the sheet, and myself, Dr. Lacombe, or one of the TAs will be filling out your points. Okay. Next up, there's another page. You guys can go through and see how this works. You get 1 point for each of these things if they're there. So please, 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 with your report and checkpoint, read the grade sheets and make sure you have everything you need. Okay. Same thing, it keeps going. We will fill in points. You need to bring in your calculations, not a spreadsheet. If you bring the spreadsheet, we can't see your formulas. So you need to handwrite out the calculations, circle the answers, make sure it's very clear to read. If you are ready to go and everything is clear and presented well, the checkpoint won't take that long and we'll get through. So make sure you are ready to go. All right, now you guys can take off. Have a great week.